Combine and simplify. 5x divided by 6 plus 4x divided by 6. Both terms already have the same denominator, so you can just add the numerators. You get 9x divided by 6. A 3 can be taken out of both the numerator and denominator. The simplified expression is 3x divided by 2. Combine and simplify. 2 divided by 3a minus 11 divided by 3a. Both terms have the same denominator, so you can subtract the numerators. You get negative 9 divided by 3a. A 3 can be taken out of both the numerator and denominator. You are left with negative 3 divided by a. Combine and simplify. X divided by 9 minus x plus 2 divided by 9. Because the denominators are the same, you could subtract the numerators. X minus the quantity x plus 2 divided by 9. Distribute the negative sign to the quantity x plus 2. X minus 2 divided by 9. The x's cancel out. You are left with negative 2/9. Combine and simplify. 2x minus 1 divided by x times the quantity x minus 3 plus 1 minus x divided by x times the quantity x minus 3. Because both terms have the same denominator, you can add the numerators. 2x minus 1 plus 1 minus x divided by x times the quantity x minus 3. Combine like terms. You get x divided by x times the quantity x minus 3. The x in the numerator and denominator cancel out. You are left with 1 divided by x minus 3. This expression has to have the same domain as the original expression. In the original expression, there was an x in the denominator. If x was equal to 0, the denominator would be equal to 0, and the expression would be undefined, so x cannot be equal to 0. The simplified expression is 1 divided by x minus 3, where x is not equal to 0. Combine and simplify. C divided by c squared plus 3c minus 4 minus 1 divided by c squared plus 3c minus 4. Both terms have the same denominator, so you can subtract the numerators. You get c minus 1 divided by c squared plus 3c minus 4. The denominator can be factored into c plus 4 and c minus 1. You are left with c minus 1 divided by the quantity c minus 1 times the quantity c plus 4. The c minus 1 in the numerator and denominator cancel out. You are left with 1 divided by c plus 4. This expression has to have the same domain as the original expression. In the original expression, there is a c minus 1 in the denominator, so c minus 1 cannot be equal to 0. C minus 1 cannot be equal to 0. Add 1 to each side. C cannot be equal to 1. The simplified expression is 1 divided by c plus 4, where c is not equal to 1. Find the least common multiple of the expressions, 5x squared and 20x cubed. Write each expression as its prime factors. 5x squared is 5 times x times x. 20x cubed is 5 times 2 times 2 times x times x times x. The least common multiple is an expression that will contain all of these factors. It has to include at least one 5, two 2's, and 3 x's. The least common multiple is 5 times 2 times 2 times x times x times x, which is 20x cubed. Find the least common multiple of the expressions 9y cubed and 12y. Write each of these expressions as their prime factors. 9y cubed equals 3 times 3 times y times y times y. 12y equals 3 times 2 times 2 times y. The least common multiple has to include each of these factors. It has to include 2 3's, 2 2's, and 3 y's. The least common multiple is 3 times 3 times 2 times 2 times y times y times y, which is equal to 36y cubed. Find the least common multiple of the expressions 5x squared and 3 times the quantity x plus 5. 15x squared can be rewritten as 5 times 3 times x times x. 3 times the quantity x plus 5 can be rewritten as 3 times the quantity x plus 5. The least common multiple has to contain each of these factors. It has to include a 5, a 3, 2 x's, and the quantity x plus 5. The least common multiple is 5 times 3 times x times the quantity x plus 5, which equals 15x squared times the quantity x plus 5. Find the least common multiple of the expressions 63z squared times the quantity z plus 1 and 14 times the quantity z plus 1 to the 4th power. 63z squared times the quantity z plus 1 can be written as 3 times 3 times 7 times z times the quantity z plus 1. And 14 times the quantity z plus 1 to the 4th power can be written as 2 times 7 times the quantity z plus 1 times the quantity z plus 1 times the quantity z plus 1 times the quantity z plus 1. The least common multiple has to contain each of these factors. So the least common multiple is 3 times 3 times 2 times 7 times z times the quantity z plus 1 times the quantity z plus 1 times the quantity z plus 1 times the quantity z plus 1, which equals 126 z squared times the quantity z plus 1 to the 4th power. Find the least common multiple of the expressions 8t times the quantity t plus 2 and 14 times the quantity t squared minus 4. 8t times the quantity t plus 2 can be written as 2 times 2 times 2 times t times the quantity t plus 2. And 14 times the quantity t squared minus 4 can be written as 2 times 7 times the quantity t plus 2 times the quantity t minus 2. The least common multiple has to contain each of these factors. It has to contain 3 2's, a t, a 7, a t plus 2, and a t minus 2. The least common multiple is 2 times 2 times 2 times t times 7 times the quantity t plus 2 times the quantity t minus 2, which equals 56t times the quantity t squared minus 4. Find the least common multiple of the expressions 2y squared plus y minus 1 and 4y squared minus 2y. 2y squared plus y minus 1 can be factored into 2y minus 1 and y plus 1. 2y can be factored out of 4y squared minus 2y. The least common multiple has to contain each of these factors. It has to contain 2y, 2y minus 1, and y plus 1. So the least common multiple is 2y times y plus 1 times 2y minus 1. Combine and simplify. 5 divided by 4x minus 3 divided by 5. First find the least common multiple of the denominators. 4x can be written as 2 times 2 times x. And 5 is already a prime number. The least common multiple has to contain each of these factors. It has to contain a 2, an x, and a 5. The least common multiple is 2 times 2 times x times 5, which is equal to 20x. Therefore, 20x is the least common denominator. Multiply 5 divided by 4x by 5 divided by 5, and 3 divided by 5 by 4x divided by 4x. 5 divided by 5 times 5 divided by 4x minus 4x divided by 4x times 3 divided by 5. Multiply the numerators and denominators. 25 divided by 20x minus 12x divided by 20x. Both terms now have the same denominator, so you can subtract the numerators. The simplified expression is 25 minus 12x divided by 20x. Combine and simplify. 7 divided by a plus 14 divided by a squared. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The first denominator is a, and the second denominator is a squared, which can be written as a times a. The least common multiple has to contain each of these factors. So the least common multiple is a squared. This means the least common denominator is a squared. You want each fraction to have a squared as the denominator. Multiply 7 divided by a divided by a. 7 divided by a times a divided by a plus 14 divided by a squared. Multiply the numerators and denominators in 7 divided by a times a divided by a. 7a divided by a squared plus 14 divided by a squared. These now have the same denominator, so you can simply add the numerators. The simplified expression is 7a plus 14 divided by a squared. Combine and simplify. 25 plus 10 divided by x plus 4. Find the least common denominator. 25 has a denominator of 1, and 10 divided by x plus 4 has a denominator of x plus 4. The least common denominator has to have each of these factors. So the least common denominator is 1 times x plus 4. You want each fraction to have a denominator of 1 times x plus 4. Multiply the first fraction by x plus 4 divided by x plus 4, and multiply the second fraction by 1 over 1. 25 times the quantity x plus 4 divided by x plus 4, plus 10 times 1 divided by the quantity x plus 4 times 1. The two fractions now have the same denominator, so you can simply add the numerators. 25 times the quantity x plus 4 plus 10 divided by x plus 4. Distribute the 25 to the x plus 4. 25x plus 100 plus 10 divided by x plus 4. Combine like terms. The simplified expression is 25x plus 110 divided by x plus 4. Combine and simplify. X divided by x plus 3 minus 5 divided by x minus 2. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The denominator of the first fraction is x plus 3, and the denominator of the second fraction is x minus 2. The least common denominator has to contain each of these terms. So the least common denominator is the quantity x plus 3 times the quantity x minus 2. You want the denominator of each fraction to be the quantity x plus 3 times the quantity x minus 2. Multiply the first fraction by x minus 2 divided by x minus 2, and multiply the second fraction by x plus 3 divided by x plus 3. x times the quantity x minus 2 divided by the quantity x plus 3 times the quantity x minus 2 minus 5 times the quantity x plus 3 divided by the quantity x minus 2 times the quantity x plus 3. Now that both fractions have the same denominator, subtract the numerators. X times the quantity x minus 2 minus 5 times the quantity x plus 3 divided by the quantity x plus 3 times the quantity x minus 2. Distribute the x to the x minus 2 and the negative 5 to the x plus 3. X squared minus 2x minus 5x minus 15 divided by the quantity x plus 3 times the quantity x minus 2. Combine like terms. The simplified expression is x squared minus 7x minus 15 divided by the quantity x plus 3 times the quantity x minus 2. Combine and simplify. 12 divided by x squared minus 9 minus 2 divided by x minus 3. Find the least common denominator. The least common denominator is going to be the least common multiple of the two denominators. The first denominator is x squared minus 9. This can be written as x plus 3 and x minus 3. The second denominator is x minus 3. The least common denominator has to include all of these factors. The least common denominator is the quantity x plus 3 times the quantity x minus 3. You want each fraction to have a denominator of the quantity x plus 3 times the quantity x minus 3. The first fraction already has this as its denominator. Multiply the second fraction by the quantity x plus 3 divided by the quantity x plus 3. You get 12 divided by the quantity x plus 3 times the quantity x minus 3 minus 2 times the quantity x plus 3 divided by the quantity x plus 3 times the quantity x minus 3. Now that each term has the same denominator, you can subtract the numerators. You are left with 12 minus 2 times the quantity x plus 3 divided by the quantity x plus 3 times the quantity x minus 3. Distribute the negative 2 to the quantity x plus 3. 12 minus 2x minus 6 divided by the quantity x plus 3 times the quantity x minus 3. Combine like terms. Subtract 6 from 12. Factor a negative 2 out of the numerator. Negative 2 times the quantity x minus 3 divided by the quantity x minus 3 times the quantity x plus 3. There is an x minus 3 in both the numerator and denominator, so they cancel out. You are left with negative 2 divided by x plus 3. This expression has to have the same domain as the original expression. In the original expression, there is an x minus 3 in the denominator, so x minus 3 cannot be equal to 0. So x cannot be equal to 3. The simplified expression is negative 2 divided by x plus 3, where x is not equal to negative 3. Combine and simplify. 20 divided by x minus 4 plus 20 divided by 4 minus x. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The two denominators are x minus 4 and 4 minus x. 4 minus x can be written as negative 1 times the quantity x minus 4. The least common denominator has to include each factor. So the least common denominator is negative 1 times x minus 4. You want each fraction to have negative 1 times the quantity x minus 4 as its denominator. Multiply the first fraction by negative 1 divided by negative 1. The second fraction already has this as its denominator. Negative 20 divided by negative 1 times the quantity x minus 4 plus 20 divided by negative 1 times the quantity x minus 4. Now that these two fractions have the same denominator, add the numerators. You are left with 0 divided by negative 1 times the quantity x minus 4, which equals 0. This expression has to have the same domain as the original expression. In the original expression, there is an x minus 4 in the denominator, so x minus 4 cannot be equal to 0. Add 4 to each side. X cannot be equal to 4. So the final solution is 0, where x is not equal to 4. Combine and simplify. 3x divided by x minus 8 minus 6 divided by 8 minus x. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The two denominators are x minus 8 and 8 minus x. A negative 1 can be factored out of 8 minus x. 8 minus x equals negative 1 times the quantity x minus 8. This means negative 1 times 8 minus x equals x minus 8. The least common denominator is x minus 8. You want each of these fractions to have a denominator of x minus 8. The first fraction already does, so you don't need to do anything to it. 3x divided by x minus 8 minus 6 times negative 1 divided by the quantity 8 minus x times negative 1. Distribute the negative 1 to the 8 minus x. 3x divided by x minus 8 minus negative 6 divided by x minus 8. Now that both fractions have the same denominator, you can subtract the numerators. Subtracting a negative number is the same thing as adding a positive number. The simplified expression is 3x plus 6 divided by x minus 8. Combine and simplify. 3x divided by the quantity 3x minus 2 plus 2 divided by the quantity 2 minus 3x. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The two denominators are 3x minus 2 and 2 minus 3x. You can factor a negative 1 out of 3x minus 2. You are left with negative 1 times the quantity 2 minus 3x. The least common denominator has to contain each factor. The least common denominator is negative 1 times the quantity 2 minus 3x, which equals 3x minus 2. Each fraction has to have this as its denominator. The first fraction already has this as its denominator. Multiply the second fraction by negative 1 divided by negative 1. 3x divided by 3x minus 2 plus 2 times negative 1 divided by the quantity 2 minus 3x times negative 1. Now that these two fractions have the same denominators, you can add the numerators. Multiply the negative 1 and the 2, and distribute the negative 1 to the 2 minus 3x. 3x divided by 3x minus 2 plus negative 2 divided by 3x minus 2. Now that both fractions have the same denominators, add the numerators. 3x minus 2 divided by 3x minus 2. The numerator and denominator are equal, so this simplifies to 1. This expression has to have the same domain as the original expression. There was originally a 3x minus 2 in the denominator of the original expression, so 3x minus 2 cannot be equal to 0. 3x minus 2 cannot be equal to 0. Add 2 to each side. 3x cannot be equal to 2. Divide each side by 3. X cannot be equal to 2/3. The simplified expression is 1, where x is not equal to 2/3. Combine and simplify. 3 divided by x minus 5 plus 2 divided by x plus 5. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The two denominators are x minus 5 and x plus 5. The least common denominator has to contain each of these factors. The least common denominator is the quantity x minus 5 times the quantity x plus 5. You want each fraction to have this as its denominator. Multiply the first fraction by x plus 5 divided by x plus 5, and multiply the second fraction by x minus 5 divided by x minus 5. 3 times the quantity x plus 5 divided by the quantity x minus 5 times the quantity x plus 5, plus 2 times the quantity x minus 5 divided by the quantity x minus 5 times the quantity x plus 5. Now that both fractions have the same denominator, add the numerators. 3 times the quantity x plus 5 plus 2 times the quantity x minus 5 divided by the quantity x minus 5 times the quantity x plus 5. Distribute the 3 to the x plus 5 and distribute the 2 to the x minus 5. 3x plus 15 plus 2x minus 10 divided by the quantity x minus 5 times the quantity x plus 5. Combine like terms. 5x plus 5 divided by the quantity x minus 5 times the quantity x plus 5. The quantity x minus 5 times the quantity x plus 5 equals x squared minus 25. The simplified expression is 5x plus 5 divided by x squared minus 25. Combine and simplify. 9 divided by 5x plus 3 divided by x minus 1. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The two denominators are 5x and x minus 1. The least common denominator has to contain each of these factors. The least common denominator is 5x times the quantity x minus 1. Each fraction has to have this as its denominator. Multiply the first fraction by x minus 1 divided by x minus 1, and multiply the second fraction by 5x divided by 5x. 9 times the quantity x minus 1 divided by 5x times the quantity x minus 1, plus 3 times 5x divided by 5x times the quantity x plus 1. Now that each fraction has the same denominator, add the numerators. 9 times the quantity x minus 1 plus 3 times 5x divided by 5x times the quantity x minus 1. Distribute the 9 to the x minus 1 and multiply the 3 and 5x. 9x minus 9 plus 15x divided by 5x times the quantity x minus 1. Combine like terms. The simplified expression is 24x minus 9 divided by 5x times the quantity x minus 1. Combine and simplify. X divided by the quantity x squared minus x minus 30 minus 1 divided by x plus 5. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The two denominators are x squared minus x minus 30 and x plus 5. X squared minus x minus 30 can be factored into the quantity x plus 5 times the quantity x minus 6. The least common denominator has to contain each of these factors. The least common denominator is the quantity x plus 5 times the quantity x minus 6. Each fraction has to have this as its denominator. The first fraction already has this as its denominator, so you do not need to multiply it by anything. Multiply the second fraction by the quantity x minus 6 divided by the quantity x minus 6. X divided by the quantity x plus 5 times the quantity x minus 6 minus x minus 6 divided by the quantity x plus 5 times the quantity x minus 6. Now that both fractions have the same denominator, subtract the numerators. X minus the quantity x minus 6 divided by the quantity x plus 5 times the quantity x minus 6. Distribute the negative sign to the quantity x minus 6. X minus x plus 6 divided by the quantity x plus 5 times the quantity x minus 6. Combine like terms. The positive x and negative x cancel out. The simplified expression is 6 divided by the quantity x plus 5 times the quantity x minus 6. Combine and simplify. 4 divided by x minus 4 plus 16 divided by the quantity x minus 4 squared. Find the least common denominator. The least common denominator is going to be the least common multiple of the two denominators. X minus 4 squared equals the quantity x minus 4 times the quantity x minus 4. The least common denominator has to include each factor. So the least common denominator is the quantity x minus 4 times the quantity x minus 4. You want each fraction to have this as its denominator. Multiply the first fraction by x minus 4 divided by x minus 4. The second fraction already has this as its denominator. 4 times the quantity x minus 4 divided by the quantity x minus 4 squared plus 16 divided by the quantity x minus 4 squared. Now that the denominators are the same, add the numerators. 4 times the quantity x minus 4 plus 16 divided by the quantity x minus 4 squared. Distribute the 4 to the x minus 4. 4x minus 16 plus 16 divided by the quantity x minus 4 squared. The positive 16 and negative 16 cancel out. The simplified solution is 4x divided by the quantity x minus 4 squared. Combine and simplify. Y divided by the quantity x squared plus x times y minus x divided by the quantity x times y plus y squared. Find the least common denominator. The least common denominator is the least common multiple of the two denominators. The two denominators are x squared plus x times y and x times y plus y squared. X squared times the quantity x plus y can be factored into x times the quantity x plus y. And x times y plus y squared can be factored into y times the quantity x plus y. The least common denominator has to contain each factor. So the least common denominator is x times y times the quantity x plus y. Each fraction has to have this as its denominator. Multiply the first fraction by y divided by y and the second fraction by x divided by x. Y times y divided by x times y times the quantity x plus y minus x times x divided by the quantity x times y times the quantity x plus y. Now that each fraction has the same denominator, subtract the numerators. Y squared minus x squared divided by x times y times the quantity x plus y. Y squared minus x squared factors into y plus x and y minus x. The quantity y plus x times the quantity y minus x divided by x times y times the quantity x plus y. The quantity y plus x and the quantity x plus y cancel out. You are left with y minus x divided by the quantity x plus y. This expression has to have the same domain as the original expression. There was originally an x plus y in the denominator, so x plus y cannot be equal to 0. Subtract y from each side. X cannot equal negative y. So the simplified expression is y minus x divided by x times y, where x is not equal to negative y. Combine and simplify. 4 divided by x minus 2 divided by x squared plus 4 divided by x plus 3. Find the least common denominator. The least common denominator is the least common multiple of the three denominators. The three denominators are x, x squared, and x plus 3. X squared equals x times x. The least common denominator has to contain each of these factors. The least common denominator is x times the quantity x plus 3, which equals x squared times the quantity x plus 3. Each fraction has to have this as its denominator. Multiply the first fraction by x times the quantity x plus 3 divided by x times the quantity x plus 3. Multiply the second fraction by the quantity x plus 3 divided by the quantity x plus 3. And multiply the third fraction by x squared divided by x squared. 4x times the quantity x plus 3 divided by x squared times the quantity x plus 3 minus 2 times the quantity x plus 3 divided by x squared times the quantity x plus 3 plus 4x squared divided by x squared times the quantity x plus 3. Now that each fraction has the same denominator, add and subtract the numerators. 4x times the quantity x plus 3 minus 2 times the quantity x plus 3 plus 4x squared divided by x squared times the quantity x plus 3. Distribute the 4x to the quantity x plus 3 and the negative 2 to the quantity x plus 3. Combine like terms. The simplified expression is 8x squared plus 10x minus 6 divided by x squared times the quantity x minus 3. Combine and simplify. 3u divided by the quantity u squared minus 2uv plus v squared plus 2 divided by the quantity u minus u divided by the quantity u minus v. Find the least common denominator. The least common denominator is the least common multiple of the three denominators. The three denominators are u squared minus 2uv plus v squared, u minus v, and u minus v. U squared minus 2uv plus v squared can be factored into the quantity u minus v times the quantity u minus v. The least common denominator has to contain each factor. The least common denominator is the quantity u minus v times the quantity u minus v, which equals the quantity u minus v squared. Each fraction has to have the quantity u minus v squared as its denominator. The first fraction already does. Multiply the second two fractions by the quantity u minus v divided by the quantity u minus v. 3u divided by the quantity u minus v squared plus 2 times the quantity u minus v divided by the quantity u minus v squared minus u times the quantity u minus v divided by the quantity u minus v squared. Now that each fraction has the same denominator, add and subtract the numerators. 3u plus 2 times the quantity u minus v minus u times the quantity u minus v divided by the quantity u minus v squared. Distribute the 2 to the u minus v and the negative u to the u minus v. 3u plus 2u minus 2v minus u squared plus uv divided by the quantity u minus v squared. Combine like terms. The simplified expression is negative u squared plus 5u plus uv minus 2v divided by the quantity u minus v squared. Use the following models, which give numbers in millions of males M and females F enrolled as undergraduate students from 2005 to 2010. M equals negative 150,000th t plus 5 and 5300ths divided by negative 49,000th t plus 1, where 5 is less than or equal to t and t is less than or equal to 10. And F equals negative 313,000th t plus 7 and 7100ths divided by negative 55,000th t plus 1, where 5 is less than or equal to t and t is less than or equal to 10. In these models, t represents the year, with t equals 5 corresponding to 2005. Find a rational model t for the number of total undergraduate students in millions from 2005 through 2010. The total number of undergraduate students will be the sum of the male undergraduate students and the female undergraduate students. Negative 150,000ths t plus 5 and 5300ths divided by negative 49,000ths t plus 1 plus negative 313,000ths t plus 7 and 7100ths divided by negative 55,000ths t plus 1. Find the least common denominator. The two denominators share no factors, so the least common denominator is going to be both denominators multiplied together. The least common denominator is a quantity negative 49,000ths t plus 1 times the quantity negative 55,000ths t plus 1. Each fraction has to have this as its denominator. Multiply the first fraction by negative 55,000ths t plus 1 divided by negative 55,000ths t plus 1, and multiply the second equation by negative 49,000ths t plus 1 divided by negative 49,000ths t plus 1. The quantity negative 150,000ths t plus 5 and 5300ths times the quantity negative 55,000ths t plus 1 divided by the quantity negative 49,000ths t plus 1 times the quantity negative 55,000ths t plus 1 plus the quantity negative 313,000ths t plus 7 and 7900ths times the quantity negative 49,000ths t plus 1 divided by the quantity negative 49,000ths t plus 1 times the quantity negative 55,000ths t plus 1. Now that these two fractions have the same denominators, add the numerators. Also, simplify the numerators by foiling. 825 hundred-thousandths t squared minus 454 thousandths t plus 5 and 53 hundredths plus 153 10 thousandths t squared minus 691 thousandths t plus 7 and 71 hundredths divided by the quantity negative 49 thousandths t plus 1 times the quantity negative 55 thousandths t plus 1. Combine like terms. The simplified expression is 236 10 thousandths t squared minus 1 and 144 thousandths t plus 13 and 24 hundredths divided by the quantity negative 49 thousandths t plus 1 times the quantity negative 55 thousandths t plus 1, where 5 is less than or equal to t and t is less than or equal to 10. Simplify the complex fraction. 3/16 divided by 9/12. When dividing fractions, invert the divisor and multiply. 3/16 times 12/9. Multiply the numerators and denominators. 3 times 12 divided by 16 times 9. Break each factor into its prime factors. 3 times 3 times 2 times 2 divided by 2 times 2 times 2 times 2 times 3 times 3. 2 3's and 2 2's cancel out. You are left with 1 divided by 2 times 2, which equals 1/4. The simplified fraction is 1/4. Simplify the complex fraction. 8x squared y divided by 3z squared divided by 4xy divided by 9z to the 5th power. When dividing fractions, invert the divisor and multiply. 8x squared y divided by 3z squared times 9z to the 5th power divided by 4xy. Multiply the numerators and denominators. 8x squared y times 9z to the 5th power divided by 3z squared times 4xy. Break each factor into its prime factors. 2 times 2 times 2 times x times y times 3 times 3 times z times z times z times z times z divided by 3 times z times z times 2 times 2 times x times y. A 3, 2 z's, 2 2's, an x and a y cancel out of the numerator and denominator. You are left with 2 times x times 3 times z times z times z. This simplifies to 6xz cubed. This expression has to have the same domain as the original expression. There was a z, an x, and a y in the denominator of the original expression. So the simplified expression is 6xz cubed, where x is not equal to 0, y is not equal to 0, and z is not equal to 0. Simplify the complex fraction. 6x cubed divided by the quantity 5y squared divided by the quantity 3x squared divided by 15y to the 4th power. When dividing by a fraction, invert the divisor and multiply. 6x cubed divided by the quantity 5y squared times 15y to the 4th power divided by the quantity 3x squared. Multiply the numerators and denominators. 6x cubed times 15y to the 4th power divided by the quantity 15y squared times the quantity 3x squared. Square the quantity 5y and the quantity 3x. 6x cubed times 15y to the 4th power divided by 25y squared times 9x squared. Write each factor as its prime factors. 3 times 2 times x times x times x times 3 times 5 times y times y times y times y divided by 5 times 5 times y times y times 3 times 3 times x. 2 x's, 2 y's, 2 3's, and 1 5 cancel out from both the numerator and denominator. You are left with 2 times x times y divided by 5, which simplifies to 2xy squared divided by 5. This expression has to have the same domain as the original expression. In the original expression, there is an x and a y in the denominator, so neither x nor y can be equal to 0. So the simplified expression is 2x y squared divided by 5, where x is not equal to 0 and y is not equal to 0. Simplify the complex fraction. The quantity y divided by 3 minus y divided by the quantity y squared divided by y minus 3. When dividing fractions, invert the divisor and multiply. Y divided by 3 minus y times y minus 3 divided by y squared. Now you can multiply the numerators and denominators together. Y times the quantity y minus 3 divided by y squared times the quantity 3 minus y. Factor a negative 1 out of 3 minus y and write y squared as y times y. Y times the quantity y minus 3 divided by negative y times the quantity y minus 3. There's a y and a y minus 3 in both the numerator and denominator, so they cancel out. You are left with negative 1 divided by y. This expression has to have the same domain as the original expression. There was originally a y and a y minus 3 in the denominator, so neither of these factors can be equal to 0. In the second equation, add 3 to each side. Y cannot be equal to 3. So y cannot be equal to 0, and y cannot be equal to 3. There is already a y in the denominator of the final expression, so there is no need to write that y cannot be equal to 0. The simplified expression is negative 1 divided by y, where y is not equal to 3. Simplify the complex fraction. The quantity 25x squared divided by x minus 5 divided by the quantity 10x squared divided by 5 plus 4x minus x squared. When dividing by a fraction, invert the divisor and multiply. You can now multiply the numerators and denominators together. Factor negative 1 out of 5 plus 4x minus x squared. Write 25x squared as 5 times 5 times x. Factor x squared minus 4x minus 5 into x minus 5 and x plus 1. And write 10x as 2 times 5 times x. There is a 5, an x, and an x minus 5 in both the numerator and the denominator, so they cancel out. You are left with negative 5 times the quantity x plus 1 divided by 2. This expression has to have the same domain as the original expression. There was originally an x and an x minus 5 in the denominator. If either of these factors were equal to 0, the denominator would be equal to 0 and the expression would be undefined. Also, before you inverted the divisor, there was a 5 plus 4x minus x squared in the denominator. This factored in a negative 1 times the quantity x plus 1 times the quantity x minus 5. So x plus 1 and x minus 5 cannot be equal to 0. In the second equation, add 5 to each side. X cannot be equal to 5. In the third equation, subtract 1 from each side. X cannot be equal to negative 1. The simplified expression is negative 5x times the quantity x plus 1 divided by 2, where x is not equal to 0, x is not equal to 5, and x is not equal to negative 1. Simplify the complex fraction. The quantity x squared plus 3x minus 10 divided by x plus 4 divided by 3x minus 6. When dividing by a fraction, invert the divisor and multiply. The divisor is 3x minus 6. 3x minus 6 is the numerator and the denominator is 1. X squared plus 3x minus 10 divided by x plus 4 times 1 divided by 3x minus 6. You can now multiply the numerators and denominators together. X squared plus 3x minus 10 divided by the quantity x plus 4 times the quantity 3x minus 6. Factor x squared plus 3x minus 10 into x minus 2 and x plus 5, and factor a 3 out of 3x minus 6. The quantity x plus 5 times the quantity x plus 2 divided by 3 times the quantity x plus 4 times the quantity x minus 2. There is an x minus 2 in both the numerator and denominator, so it cancels out. You are left with x plus 5 divided by 3 times the quantity x plus 4. This expression has to have the same domain as the original expression. In the original expression, there is an x minus 2 in the denominator. so x minus 2 cannot be equal to 0. Add 2 to each side. X cannot be equal to 2. The simplified expression is x plus 5 divided by 3 times the quantity x plus 4, where x is not equal to 2. Simplify the complex fraction. 2x minus 14 divided by the quantity x squared minus 9x plus 14 divided by x plus 3. When dividing by a fraction, invert the divisor and multiply. 2x minus 14 divided by 1 times x plus 3 divided by x squared minus 9x plus 14. 2x minus 14 has a denominator of 1, because any expression that does not already have a denominator can be written as a fraction with a denominator of 1. Multiply the numerators and denominators. The quantity 2x minus 14 times the quantity x plus 3 divided by x squared minus 9x plus 14. Factor a 2 out of 2x minus 14 and factor x squared minus 9x plus 14 into x minus 7 and x minus 2. Because there is an x minus 7 in both the numerator and denominator, they cancel out. You are left with 2 times the quantity x plus 3 divided by x minus 2. This expression has to have the same domain as the original expression. In the original expression, there was an x minus 7 in the denominator, so x minus 7 cannot be equal to 0. Also, before inverting the divisor, there was an x plus 3 in the denominator, so x plus 3 cannot be equal to 0. Solve each of these for x. In the first one, subtract 3 from each side. X cannot equal negative 3. In the second one, add 7 to each side. X cannot equal 7. The simplified expression is 2 times the quantity x plus 3 divided by x minus 2, where x is not equal to negative 3 and x is not equal to 7. Simplify the complex fraction. The quantity 6x squared minus 17x plus 5 divided by 3x squared plus 3x divided by the quantity 3x minus 1 divided by 3x plus 1. When dividing fractions, invert the divisor and multiply. 6x squared minus 17x plus 5 divided by 3x squared plus 3x times 3x plus 1 divided by 3x minus 1. Multiply the numerators and denominators. The quantity 6x squared minus 17x plus 5 times the quantity 3x plus 1 divided by the quantity 3x squared plus 3x times the quantity 3x minus 1. Factor 6x minus 17x plus 5 into 3x minus 1 and 2x minus 5. And factor a 3x out of 3x squared plus 3x. The quantity 3x minus 1 times the quantity 2x minus 5 times the quantity 3x plus 1 divided by 3x times the quantity x plus 1 times the quantity 3x minus 1. There is a 3x minus 1 in both the numerator and denominator, so they cancel out. You are left with the quantity 2x minus 5 times 3x plus 1 divided by 3x times the quantity x plus 1. This expression has to have the same domain as the original expression. There was a 3x minus 1 in the denominator, so 3x minus 1 cannot be equal to 0. Also, before inverting the divisor, there was a 3x plus 1 in the denominator, so 3x plus 1 cannot be equal to 0. In the first equation, subtract 1 from each side. 3x cannot be equal to negative 1. Divide each side by 3. X cannot be equal to negative 1/3. In the second equation, add 1 to each side. 3x cannot be equal to 1. Divide each side by 3. X cannot be equal to 1/3. So the simplified expression is the quantity 2x minus 5 times the quantity 3x plus 1 divided by 3x times the quantity x plus 1, where x is not equal to positive or negative 1/3. Simplify the complex fraction. The quantity is 16x squared plus 8x plus 1 divided by 3x squared plus 8x minus 3, divided by the quantity 4x squared minus 3x minus 1 divided by x squared plus 6x plus 9. When dividing by a fraction, invert the divisor and multiply. Now multiply the numerators and denominators together. 16x squared plus 8x plus 1 factors into 4x plus 1 times 4x plus 1. X squared plus 6x plus 9 factors into x plus 3 times x plus 3. 3x squared plus 8x minus 3 factors into 3x minus 1 and x plus 3. And 4x squared minus 3x plus 1 factors into 4x plus 1 and x minus 1. There is a 4x plus 1 and an x plus 3 in both the numerator and denominator, so they cancel out. You are left with the quantity 4x plus 1 times the quantity x plus 3 divided by the quantity 3x minus 1 times the quantity x minus 1. This expression has to have the same domain as the original expression. In the original expression, there was an x plus 3 and a 4x plus 1 in the denominator. If either of these factors were equal to 0, the denominator would be equal to 0 and the expression would be undefined. So these factors cannot be equal to 0. X plus 3 cannot be equal to 0, and 4x plus 1 cannot be equal to 0. Solve each of these for x. In the first one, subtract 3 from each side. X cannot be equal to negative 3. In the second one, subtract 1 from each side. 4x cannot be equal to negative 1. Divide each side by 4. X cannot be equal to negative 1/4. The simplified expression is the quantity 4x plus 1 times the quantity x plus 3 divided by the quantity 3x minus 1 times the quantity x minus 1, where x is not equal to negative 3 and x is not equal to negative 1/4. Simplify the complex fraction. X squared plus x minus 6 divided by x squared minus 4 divided by x plus 3 divided by x squared plus 4x plus 4. When dividing by a fraction, invert the divisor and multiply. X squared plus x minus 6 divided by x squared minus 4 times x squared plus 4x plus 4 divided by x plus 3. Multiply the numerators and denominators together. X squared plus x minus 6 factors into x plus 3 and x minus 2. X squared plus 4x plus 4 factors into x plus 2 and x plus 2. And x squared minus 4 factors into x plus 2 and x minus 2. There is an x plus 2, an x minus 2, and an x plus 3 in both the numerator and denominator, so they cancel out. You are left with x plus 2. This expression has to have the same domain as the original expression. In the original expression, there's an x plus 2, an x minus 2, and an x plus 3 in the denominator. So x plus 2 cannot be equal to 0, x minus 2 cannot be equal to 0, and x plus 3 cannot be equal to 0. In the first equation, subtract 2 from each side. X cannot equal negative 2. In the second equation, add 2 to each side. X cannot equal 2. In the last equation, subtract 3 from each side. X cannot equal negative 3. The simplified expression is x plus 2, where x is not equal to negative 2, 2, or negative 3. Simplify the complex fraction. The quantity x squared minus 3x minus 10 divided by x squared minus 4x plus 4, divided by the quantity 21 plus 4x minus x squared divided by x squared minus 5x minus 14. When dividing by a fraction, invert the divisor and multiply. X squared minus 3x minus 10 divided by x squared minus 4x plus 4 times x squared minus 5x minus 14 divided by 21 plus 4x minus x squared. Multiply the numerators and denominators together. X squared minus 5x minus 14 factors into x minus 7 and x plus 2. X squared minus 4x plus 4 factors into x minus 2 and x minus 2. 21 plus 4x minus x squared factors into negative 1 times x minus 7 times x plus 3. There is an x minus 7 in the numerator and denominator, so they cancel out. You are left with negative the quantity x minus 5 times the quantity x plus 2 squared, divided by the quantity x plus 3 times the quantity x minus 2 squared. This expression has to have the same domain as the original expression. There was originally an x minus 7 in the denominator, so x minus 7 cannot be equal to 0. Before you inverted the divisor, x squared minus 5x minus 14 was in the denominator. This factored in x minus 7 and x plus 3. So x plus 3 cannot be equal to 0. Solve each of these for x. In the first one, add 7 to each side. X cannot be equal to 7. In the second one, subtract 3 from each side. X cannot be equal to negative 3. The simplified expression is negative the quantity x minus 5 times the quantity x plus 2 squared, divided by the quantity x plus 3 times the quantity x minus 2 squared, where x is not equal to negative 3 or 7. Simplify the complex fraction. The quantity 1 plus 4 divided by y. Get rid of the fractions in the numerator. There is a 4 divided by y in the numerator. Multiply both the numerator and denominator by y, so that the 4 divided by y is just 4. Multiply the numerators and denominators. Y times the quantity 1 plus 4 divided by y squared. Distribute the y to the 1 plus 4 divided by y. The simplified expression is 4 plus y divided by y squared. Simplify the complex fraction. The quantity 4 divided by x plus 3 divided by the quantity 4 divided by x minus 3. Both the numerator and denominator contain the fraction 4 divided by x. In order to get rid of the fractions in the numerators and denominators, multiply the entire fraction by x divided by x. Multiply the numerators and denominators. Distribute the x to the 4 divided by x plus 3 and the x to the 4 divided by x minus 3. You are left with 4 plus 3x divided by 4 minus 3x. This expression has to have the same domain as the original expression. In the original expression, there is a fraction 4 divided by x. X is in the denominator of this fraction, so x cannot be equal to 0. The simplified expression is 4 plus 3x divided by 4 minus 3x, where x is not equal to 0. Simplify the complex fraction. The quantity x divided by 2 divided by the quantity 2 plus 3 divided by x. Because there are fractions in both the numerator and denominator, multiply both the numerator and denominator by the least common denominator of the two fractions. The two denominators are 2 and x. The least common denominator has to contain each of these as factors. So the least common denominator is 2x. Multiply the numerators and denominators and distribute the 2x in the denominator. X divided by 2 times 2x divided by 2 times 2x plus 3 divided by x times 2x. In the numerator, the 2's cancel out. And in the second term of the denominator, the x's cancel out. You are left with x squared divided by 4x plus 6. You can factor a 2 out of the denominator. X squared divided by 2 times the quantity 2x plus 3. This expression has to have the same domain as the original expression. In the original expression, there is an x in the denominator of 3 divided by x, so x cannot be equal to 0. The simplified expression is x squared divided by 2 times the quantity 2x plus 3, where x is not equal to 0. Simplify the complex fraction. The quantity 3 plus 9 divided by x plus 3 divided by the quantity 4 plus 12 divided by x plus 3. Both the numerator and denominator contain a fraction with the denominator of x minus 3. To make these terms no longer fractions, multiply the entire fraction by x minus 3 divided by x minus 3. 3 plus 9 divided by x plus 3 divided by 4 plus 12 divided by x plus 3 times x minus 3 divided by x minus 3. Multiply the numerators and denominators and distribute the x minus 3's. 3 times the quantity x minus 3 plus 9 divided by 4 times the quantity x minus 3 plus 12. Factor a 3 out of the numerator and a 4 out of the denominator. 3 times the quantity x minus 3 plus 3 divided by 4 times the quantity x minus 3 plus 3. Combine like terms. The 3 and negative 3 cancel out. You are left with 3x divided by 4x. There's an x in both the numerator and denominator, so they cancel out. You are left with 3/4. This expression has to have the same domain as the original expression. There was an x in the denominator, so x cannot be equal to 0. There was also an x minus 3 in the denominator, so x minus 3 cannot be equal to 0. Add 3 to each side. X cannot be equal to 3. The simplified expression is 3/4, where x is not equal to 0 or 3. Simplify the complex fraction. The quantity 1 divided by x minus 1 divided by x plus 1 divided by 1 divided by x plus 1. Make the fractions that are in the numerator and denominator no longer fractions. To do so, multiply the entire expression by the least common denominator divided by the least common denominator. The three denominators are x, x plus 1, and x plus 1. The least common denominator has to contain each of these as factors. The least common denominator is x times the quantity x plus 1. So multiply this expression by x times the quantity x plus 1 divided by x times the quantity x plus 1. Multiply the numerators and denominators and distribute. You are left with x plus 1 minus x divided by x. The positive x and negative x in the numerator cancel out. 1 divided by x. This expression has to have the same domain as the original expression. In the original expression, there was an x plus 1 in the denominator, so x plus 1 cannot be equal to 0. Subtract 1 from each side. X cannot be equal to negative 1. The simplified expression is 1 divided by x, where x is not equal to negative 1. Simplify the complex fraction. 2y minus y to the negative first power divided by 10 minus y to the negative second power. Y to the negative first power can be written as 1 divided by y, and y to the negative second power can be written as 1 divided by y squared. 2y minus 1 divided by y divided by 10 minus 1 divided by y squared. Because there are fractions in the numerators and denominators, multiply the numerator and denominator by the least common denominator of the two fractions. The two denominators are y and y squared. The least common denominator has to contain each of these as factors. Y is already a factor of y squared, so the least common denominator is y squared. Multiply both the numerator and denominator by y squared, and distribute the y squared. 2y times y squared minus 1 divided by y times y squared divided by 10 times y squared minus 1 divided by y squared times y squared. Y squared times 1 divided by y is y, and 1 divided by y squared times y squared is 1. 2y cubed minus y divided by 10y squared minus 1. Factor a y out of the numerator. This expression has to have the same domain as the original expression. In the original expression, there is a y in the denominator of 1 divided by y and 1 divided by y squared, so y cannot be equal to 0. The simplified expression is y times the quantity 2y squared minus 1 divided by 10y squared minus 1. Simplify the complex fraction. 7x squared plus 2x to the negative first power divided by 5x to the negative third power plus x. X to the negative first power equals 1 divided by x, and x to the negative third power equals 1 divided by x cubed. There are fractions in the numerator and denominator, so multiply both the numerator and denominator by the least common denominator of the two fractions. The two denominators are x and x cubed. X is a factor of x cubed, so the least common denominator is x cubed. Multiply both the numerator and denominator by x cubed. 7x squared times x cubed simplifies to 7x to the fifth power. 2 divided by x times x cubed simplifies to 2x squared. 5 divided by x cubed times x cubed simplifies to 5, and x times x cubed simplifies to x to the fourth power. Factor an x squared out of the numerator. This expression has to have the same domain as the original expression. In the original expression, there was an x in the denominator of 2 divided by x and 5 divided by x cubed, so x cannot be equal to 0. The simplified expression is x squared times the quantity 7x cubed plus 2, divided by x to the fourth power plus 5, where x is not equal to 0. When two resistors of resistance R1 and R2, all in ohms, are connected in parallel, the total resistance in ohms is modeled by 1 divided by the quantity 1 divided by R1 plus 1 divided by R2. Simplify this complex fraction. Start by adding the two fractions in the denominator. 1 divided by R1 plus 1 divided by R2. The least common denominator is R1 times R2. For each of these fractions to have this denominator, multiply the first one by R2 divided by R2, and the second one by R1 divided by R1. Now multiply the numerators and denominators. 1 divided by the quantity R2 divided by R1 times R2, plus R1 divided by the quantity R1 plus R2. These two fractions have the same denominators, so you can add the numerators. 1 divided by the quantity R1 plus R2 divided by R1 times R2. When dividing by a fraction, invert the divisor and multiply. 1 times R1 times R2 divided by R1 plus R2. This is equal to R1 times R2 divided by R1 plus R2.